Currently I'm looking for a nice example to show you something about the robots, possibilities of PowerMill. So we use the standard PowerMill Ultimate here, which includes PowerMill robots. I think I'm gonna load this project for us, because these are a few prepared demonstrations for robots. When it has been loaded, let's have a look at what we do have here. As you can see, this is a car, and when we do
car, no name car.
Okay, right. No name car, of course, yes. And when you want to cut, for example, the area of the window or part of this, because it is a clay model, for example, for the design in the automotive, then robots are quite often used. So let's have a look at a few examples to, for example, cut a part here. So we see a tool here on a surface, and when we let that move, you can see the simulation of the tool, of course. But that is not all of the truth. You want to see the machine that does that as well. And in your case, it's going to be a robot, as far as I heard. So, as a next step, let's add the robot. So, you may understand that the programming of all the moves of the tool is what you do first. And after that, the next step will be to have the robot part of PowerMill added. And here we see the robot, for example, and the robot cell. So, we would like to choose the robot we have in our situation to cut this. Let's see what we do have here. I think it is an Autodesk robot, to be honest. There are many Autodesk robots, just with demos.
I don't.
You don't do Autodesk robots? What robot do you have?
ABB Fanuc for the Kuka.
Okay. Let's have a ABB robot, for example. That could be on a linear track, for example. Let's take that. As a next step, the robot is being loaded, and of course that is not at the right position. It doesn't know where the parts are. So as a next step, we will have to tell the software where the part is. So you now already see that we do have collision checking. You see all the parts of the robot that collide with your model in red now. Oh, without me doing anything. So it always checks for collisions. That's very important, of course. So as a next step, we could tell the software where we are. So where the position of the part is. So let's have a look. If we do the logo, the face, I will make those parts visible so that I can check. Let's take the front face. I think that is the position where we want the robots to be. That is the front right. Okay, yes. So this could be a possibility to position it. Of course, normally I would position the car here and have it stand here, but we will check if this is possible, for example. So let's, for example, cut the front logo of the machine. That is here. So we want to cut these moves with this robot on this car. Can we do that? Yes or no? Let's just try if that is possible. So we go to the next step and say, okay, position the robot at the position where we want to cut. And now we see not only the tool, we see the position where we are going to cut and the full robot. And as a next step, and let's do that with the recording on, let's see what works. And in this case, you see the full simulation of the moves of the tool, your robot, of course, And this is not only showing the moves, it's constantly checking on the good collisions.
Every axis, yeah, you can see.
Yes, exactly. You saw that already. These are all the axes of the machine. A1, the lower one, A2, you can count up all the way to the spindle, which is number 6. And there is a static rail as well. So, let's move away to the beginning again and say that the robot is a bit further away. So we're going to position the robot in this situation. Can we then still machine that? Then it's going to try that with the disposition of the robot. And let's have a look. Well, to be honest, this looks better. I like that more. The robot is a bit further away, the chances for collisions are less. So, PowerMill is a system that allows you to do all the operations that are needed on a mold, a car, whatever it is, foam parts, wooden parts, etc., and simulate that next. It will in the end give you the NC code that is necessary for this robot, in the right language of course, and it will have that all checked for you to make sure that you can produce this. And that is what we do as Autodesk. Is this different from what you do? You were talking about other products.
Yeah.
Can you compare those two?
Can we make downloads of a program this when I finished, and I want to make downloads from this robot and download after that download in real robot.
Sorry?
Downloads of this robot.
Export.
Yeah.
Export to robot.
Yes.
Oh, yeah.
Because that is what you finally need,
The
of
program.
course. You will need the NC code for this robot with all the lines describing all the moves it is going to do. And that is what we do. Yes, in the end you will get the full list of all the things the robot has to do. All the steps, all the links, etc. So the NC program for the robot is the last step that you have to do. That is what the Chroma does for you. Okay. So here you can see how the robot is set up on a table, on a linear track. On a linear track there's part 1. This is the first axis, second axis, and then all the